Now, example 6 is a case where we are not dealing with the standardized normal distribution, but rather we have a normally distributed data set with a mean of $35 and a standard deviation of $5.20. So if we select a random value from this data, what is the probability that it will be between $30 and $38 per hour? Or in part B, more than $40 per hour. So we've got several, you can see that we've got several little questions to answer, but again, they will all be relative to the standardized normal distribution. And what we're going to do is we're going to concentrate on making our drawings and standardizing them using our Z values or our Z tables. So in this case, if we know that the mean is $35, so let's label the center of our distribution. Mean is equal to $35, and the standard deviation or measure of spread is $5.20. So we've got a middle or a mean value of $35, and we want to know what proportion of or what is the probability that the value that we draw will be between $30 and $38 per hour. So $30 per hour is going to be to the left of the mean. So let's just say it's going to be approximately here. So $30 per hour will be to the left of the mean, and $38 per hour is going to be to the right of the mean. So it'll be right here. So $38. And so now what we need to do now is to say, I've got to find out what the area is between those two values. And so what I'm going to need to do is to calculate some Z values or relate it back to the standard normal distribution, which has a center at 0 and a standard deviation of 1. So I'm going to use the formula for the Z value. The Z value is going to be x minus mu over sigma. And so we have two x values here. So I'm going to say Z1 is going to be $30. So it'll be $30 minus the mean, which is 35, divided by the standard deviation, which is 5.2. And that Z value corresponds to a Z value of negative 0.96. Remember that the Z value just tells me how many standard deviations I am away from the mean. So this tells me that I am 0.96 standard deviations to the left of the mean. That's what that negative Z value tells me. Now, of course, along with that, I'm going to need to get an area for that. Now, I will also calculate the other Z value. The other Z value, we'll call that Z2, is the Z value for the $38 per hour. And that's going to be $38 minus the mean, $35. I want to find out how far away this number is from the mean with respect to the standard deviation of $5.20. So that's why I use this relationship, x minus mu over sigma. The second Z value is going to be equal to 0.58. In other words, this is 0.58 standard deviations to the right of the mean. Of course, I also need to get an area that corresponds to that Z value. So now I'm going to go to my normal tables and get an area for this negative Z value and get an area for the positive Z value. And I'm going to do something with those two areas. And so for a Z value of negative 0.96, I'm going to go down to 0.9 and read across to 0.96 and circle that. That would be 33.15%. So negative 0.96 corresponds to an area of 33.15%. And now to read for the area of Z value of positive 0.58, 0.58 would be 0.5 and across to the 8, that would be 21.9%. So circle those two areas and make a note of them. And so the area for the first Z value was 33.15%, and the area for the second Z value was 21.9%. So I'm going to go back to my diagram now and to place them. 33.15% for that negative Z value of negative 0.96. So that would be 33.15% for the area between 30 and 35. So between 30 and 35, we've got 33.15% of the area. And then between 38 and 35, we've got another 21.9%. So what do you think we're going to do in this particular case? Well, to find the probability of drawing a sample that was somewhere between 30 and 38, what we're going to do is add the two areas together. So the probability that X is going to be somewhere between 30 and 38 is going to be equal to 33.15 plus 21.9%. Or the probability of drawing somebody with a value between 30 and 38 will be a total of 55.05%. Now let's consider part B. What is the probability that if we select a random value from the data, what's the probability that it's going to be more than $40 per hour? So let's take a look at that and how it fits in with our diagram. So where is the $40 per hour? Well, the $40 per hour is going to be to the right of the mean. So there's our $40 per hour. Let's label that. So this $40 per hour. And what is the probability that the x value, let's write that down in notation form, probability that the x value will be greater than $40 per hour. So in other words, I want an area in the area to the right of the $40 per hour. So I want that area. I need to know that in order to, what proportion of the area under the curve is that represented by. So I need to know what the z value is. So I'm going to start off with my z calculations. And my z value, remember, is x minus mu over sigma. How far away from the middle is that value of 40? So my z calculation is going to be 40 minus the mean, which is 35, divided by the standard deviation, which is $5.20. So that z value works out to be positive 0.96. And now we've got relative to the standardized normal distribution, what that tells us is that we are 0.96 standard deviations above the mean. So I'm going to look up the area in my normal tables for that z value. And that area will work out to be 33.15%. So 33.15% is the area between 0 and 0.96 standard deviations. So now I'm going to label that area on my curve, so 33.15%. And so what, in order for me to answer the question, what is the area that's to the right of 40 or greater than 40? Well, I'm just going to subtract that from 50% because exactly half of the area is to the right of the middle or to the right of the mean. So therefore, the probability that x is going to be greater than 40 is going to be equal to 50% take away 33.15%. And that works out to be exactly 16.85%. So the probability that we draw a value from this that is greater than 40 works out to be 16.85%. So now let's take a look at part C. Again, we've got the mean is equal to $35 per hour, and the standard deviation is $5.20. This time we want to answer the question, if we select a random value from the data, what's the probability that it's less than $30 per hour? So in other words, using notation format, what is the probability that x will be less than $30 per hour? And that probability will be given by the area under the curve. So where is the $30 per hour? Well, if the mean is at $35 per hour, $30 per hour is going to be approximately here to the left of the mean. So I'm going to calculate the z value. So the z value is going to be x minus the mean over the standard deviation. And substituting, we will end up having, for that x value, we'll have 30 subtract 35 divided by the standard deviation of $5.20. So that z value is going to be minus $5 divided by $5.20. That z value corresponds to negative 0.96. So that tells me that this a value of 30 is exactly 0.96 standard deviations below the mean. So if this mean was at 0, that would be at negative 0.96 standard deviations below the mean. I need to find an area that corresponds to that, and that area we've already determined from our normal tables is 33.15%. So that means that the area between the 30 and the 35, or between 0 and negative 0.96, is 33.15%. So what area am I looking for? I'm looking for the area that's less than $30 per hour. So in other words, I'm looking for this area that I've got shaded right here. And that area, of course, corresponds to 50% of the area, take away the 33.15%. So the probability that x is going to be less than 30 is going to be equal to 50% take away 33.15%. In other words, the probability that x is going to be less than 30 is equal to it will be equal to 16.85%. So now let's take a look at part D. What is the probability that if we select a random value from the data, what's the probability that it will be at least $25 per hour? So what does that mean, at least $25 per hour? Well, in this particular case, my x value is going to be to the left of the mean. So $25 per hour is going to be somewhere along here on the left side of the mean. And at least $25 per hour means something. Does it mean more than $25 or less than $25? Well, first of all, let's calculate what the z value is. So that z value is going to be x minus the mean over the standard deviation. I like to write down the formulas every time I use it. It helps to internalize it. So that x value is going to be 25, and I'm going to subtract the mean, which is 35, and I divide that by the standard deviation, which is 5.20. And so that gives me negative $10 divided by 5.2. The z value works out to be a value of negative 1.92. And now what I need to do is go to my Z tables and get the area for that. And when I move over to my Z tables, for a Z value of 1.9, and I scroll across to the right-hand column, 1.92, and I'll circle that, it's 47.26%. So now I have the area of 47.26%. and I can mark it on my diagram. So between 25 and 35, between these two numbers, between 25 and 35, we can account for 47.26% of the distribution. So 47.26% of the distribution between the mean and 25. Now, let's go back to the original question, which was, what does at least $25 per hour mean? So what do we mean by at least 25? At least 25 means $25 or more. Certainly not less than 25. That would be less than $25. We want $25 or more, which would mean is what we mean by at least $25. So in other words, the probability that x will be greater than or equal to $25. And so what that means is that we need to know the area that's all to the right of that $25. So in other words, we need to take the 47% plus the 50% that's to the right of that mean. So that probability would be equal to 47.26% plus the 50%, which adds up to a total of 97.26%. So the probability that we draw a value that is at least $25 per hour will be 97.26%. And again, you should appreciate the importance of making a drawing so that you know whether you're dealing with values to the left or values to the right. And so the last question is that if we select a random value from this data, what is the probability that it will be at most $38 per hour? So what do we mean by at most $38 per hour? Well, first of all, let's go to our table or our graph of our distribution, our normal distribution. The mean is 35, the standard deviation is 5.2, and we want to know what is the probability that it is at most $38 per hour. So $38 per hour is going to be to the right of the mean. So $38 per hour is going to be here. And at most, what does at most mean? It means no more than. So at most means this area here to the left of that $38. So again, we're going to start off with a z value, and the z value is x minus the mean over the standard deviation. Our z value will be $38 minus the mean of $35 divided by the standard deviation of 5.2. This works out to a z value of positive 0.58. And so now what we need to do is go to our normal distribution tables and get an area that corresponds to 0.58 standard deviation. So let's do that. With our normal distribution, there is 0.5, and reading across to 0.58, I'm going to stop at 0.58. Here it is right here, 21.9%. So I've got an area of 21.9%, and that's the area between 38 and 35. So 21.9% is the area between the mean and the 38 value. So in order to answer the question, what is the probability that the X value will be at most $38 per hour, I need to take the half of the area that's to the left of the mean and add it to the 21.9%. So using the notation, what is the probability that the X value is less than or equal to $38 per hour is going to be equal to 50% plus the 21.9%, and so that gives me a grand total of 71.9%. So 71% of the samples, the values that we draw from this data, will have a value that is no more than $38 per hour.